kangaroo.
You got that.
He's a kangaroo.
The kangaroo's hopping. All right, we're going to be talking about that. 4.5 scientific notation, multiplication, and division applications. But at the beginning, I'm going to show you a little bit of the metric system. All right? Because you're going to be using this and applying it into your worksheets today. Now, when we're talking about this, then like you said, if you guys were Mr. Suckers when you've been talking about this, what did you compare? Like if I want to say a gram is in mass, a weight, about what? You would say it's about, what can we compare it to? One small paper clip. One small paper clip is approximately 1 gram. Then you have a kilogram, because if you're in size, you were just talking about kilograms, hectograms, decograms, grams, liters, or meters. And then we have decigrams, centigrams, or centimeters. Oops, I don't want to put that with it. And milli. Deca, deca. You have grams, liters, or meters. Then you have deca, centa, and milla. Now, we were just talking about what? Kangaroos hopping
Down mountains, drinking chocolate milk.
Got it. So if you wanted to change something from meters into centimeters, the kangaroo would have to hop 2 to the
Right.
So you would move your decimal 2 to the right to change it into centimeters. Or that's the same as multiplying it times what? 2 zeros, 2 hops, 100. Okay? If I wanted to go from liters to kiloliters, the kangaroo would have to hop 1, 2, 3 to the left. So you would move your decimal in your answer 3 to the left and turn liters into kiloliters, or meters into kilometers, or grams into kilograms. All right? One more time. What is this?
Kangaroo hopping down mountains, drinking chocolate milk.
Yes, that's another way to remember it. All right, and clear? How about that? So we know 1 gram is about a small paper clip. 1 kilogram then, because like I said, if I have 1 gram, that equals how many kilograms? Kangaroos hopping down mountains, drinking chocolate milk. If I have 1 gram, where's that at? Right here, liters, meters, grams. So I have a gram, I'm right here. If I want to go to kilograms, how many hops is that? Boing, boing, boing. 3 hops to the left. Here's your decimal. Boing, boing, boing. So 1 gram equals 0.001 kilogram. This minute little part of it, right? That's how small a gram is to a kilogram. Well, if we said 1 gram is 1 paper clip, 1 small paper clip, one way to look at a kilogram, especially since some of you are just baking cookies, you buy that small bag of sugar. I think it's like a small 5-pound bag of sugar. So about a half of that. So about a half of a bag of sugar. Small bag, not the big bag. Just to kind of give you an idea of what it would feel like if you were holding it. All right? So that's when we're dealing with mass or grams. Now let's talk about length. Now we're talking meters. Again, you still have that kangaroo hopping down mountains, drinking chocolate milk. 1 millimeter is approximately 1/5 of a, what does this stand for in your baking? What does that stand for? Teaspoon. TSP is teaspoon. TBL? Tablespoon. TBLS. So 1/5 of a teaspoon is in 1 milliliter. How many milliliters in a full teaspoon then?
5.
Nice. 5. 1/5 of the teaspoon is a milliliter. How many milliliters in a full teaspoon? Well, you would need all 5 of them. You would need 5 milliliters to make 1 teaspoon.
That says milliliter.
Milli. Oh, shoot, I'm on the wrong one. Here, let's fast forward. Right here, this is the one I'm on, sorry. Thank you. So this is 1/5 of a teaspoon. Now, 1 liter, you guys know that because you love to buy Mountain Dew in what kind of bottle? A bigger?
2 liters.
Friday night, movie night, you'd rather sit in front of the TV and have a big, what? 2-liter bottle of whatever kind of pop it is you like. So you know that 1 liter is half of a 2-liter bottle. Not a little bottle, a liter. I can spell. It's been a long day. All right. So that's talking volume. That is liter now that I'm on the right one. Okay, let's go back again. I'm jumping all over here today. Now that I'm on the right one again, it's teaspoon. Let's go to the millimeter measuring. I should have known that too. I sat and circled the tape measure. A millimeter is approximately, hold up your pencil. 1 millimeter is approximately the width of what? Your number 2 pencil lead. That's about 1 millimeter, the width of your pencil lead. Hold up your hand. What on your hand is about 1 centimeter wide?
Fingernail.
1 pinky, your little pinky.
Wide or like long?
I got a really wide.
Not long, now wide. Then we have 1 meter. You all see that I have this meter stick over here. Now if I hold up a yardstick, which I can't find yet, but I hold up my yardstick next to my meter stick, which one's bigger?
Yard. Meter.
A meter is. A meter, if I were to hold them up right next to each other, a meter would be about that much longer. About what is that? It's about 3 inches larger than a yard. So then we're talking kilometers. Kilometer, kilometer, tomato, data. So a kilometer is approximately,
A mile.
nope, good guess though. Think smaller. It's approximately 0. Little bit bigger than a half of a mile. So what would it be?
0.75.
Smaller, little bit bigger than half?
60.
Yeah, it's about 0.6 of a mile. So it's a little bit more than a half of a mile. 1 kilometer is a little more than a half a mile. Okay, now that we had jumped ahead earlier, I checked our notes and the notes run off are exactly, I checked them with the ruler and they are right. So take your pencil lead, hold it up here. Is your pencil lead about 1 millimeter wide? Does it work on yours? It should. Yours are to scale in your notes. So if you hold your pencil lead up here, 1 millimeter should be. Does that work?
Yeah.
Pretty close? Yep, it's a good approximation. Now hold your pinky up here on the centimeter one. Is your pinky as wide as about 1 centimeter?
No.
No.
Some of the big guys in here are saying no, and that's okay. But the average pinky is usually about 1 centimeter wide. All right, and here we talked about the metric system. One more time, let's hear it. What is this?
Kangaroos.
Well, that was pathetic. One more time. Kangaroos.
Hopping down mountains, drinking chocolate milk.
That was awesome. That could be a music teacher. Okay, let's see what we do. And on your worksheets, you don't have to write all. You can circle them as well. Your mass, your weight. What would you measure that in? Grams or kilograms?
Grams.
Grams? Do you want to put a bunch of little
Gram.
paper clips, or do you want to use half bags of sugar? So you're going to want to use kilograms. How about your height? Are you going to want to measure it in centimeters or millimeters?
Millimeters.
Would you rather measure it with your pinky or the width of your leg? Your pinky, so that would be centimeters. The volume of a can of pop. Now be careful before you answer this. A liter or milliliter?
Milliliter.
Because a can of pop, right, and that's smaller than a liter, so we couldn't use the liter. We'd have to use the milliliters. How about the weight of your pencil? Grams, because that would be like the paper clips, right? How about the distance from West Fargo to Minneapolis?
Kilometers.
Yes. Kilometers, kilometers, that's what you'd want to use. And then last, how about to measure the volume? How much gas is in your tank?
Liters.
That you could use liters. Okay, let's skip these two. We did these two this morning. We'll do these two with you guys. What they want you to do is estimate what we were just doing. We were just circling. Which one of these would be best? The volume of a bucket is about 4 what? Milliliters or liters? A bucket?
How big is the bucket?
Liters.
Well, like this. What would you want to use?
Liters.
You'd want to use liters. Okay? So what do we know? 4 liters, right? Then they say rewrite it in scientific notation using the other label. So I have to figure out how many 4 liters equals in what? Milliliters. So that takes us back to kangaroos hopping down mountains, drinking chocolate milk. Now I'm going from meters, grams, liters. I'm going from there to what? I'm going from liters to milliliters, little ones. So 1, 2, 3. That's like multiplying times what?
It'd be 1,000.
It's like multiplying by 1,000 or moving your decimal how many places?
3.
Because we went 1, 2, 3. So what? How many milliliters is 4 liters?
4,000.
4,000. Okay, we've converted. So far we're right. Because they say rewrite it in scientific notation now.
Yeah, but it's bigger than.
So we need to rewrite this in scientific notation. Where does my decimal have to be?
That's
4. Right here. So we had to move it in how many times?
3.
So we're going to take 4
Times 3.
times 10 to the third power. Why isn't it a negative 3? We move to the left.
We move, because if you move to the left, you're going.
Right, and our original number is a whole number, isn't it? It's not a decimal. Excellent. All right, so let's try this one. The distance across the classroom is about 1.55 times 10 to the, is that a 1? I don't know.
Yeah.
To the first power. Is that centimeters or meters measuring across our classroom? A meter stick or your pinky?
Meters.
Your meter stick. Okay, so this is meters. We need to convert. Now this is in scientific notation, isn't it? So we have to first convert that to what? Form. Standard form. What will this be in standard form? 15.5 meters. There we go. Now it's in standard form. Now I need to turn meters into what? What's the other one? Centimeters. Now how many does my kangaroo have to hop to get from meters to centimeters? 1, 2. That's like multiplying it times 100. Moving it to the right twice. What do I get? Boing, boing.
550.
So these two are equal. These two equal each other. 15.5 meters is exactly the same as 1,550 centimeters. Done, right?
No.
Good answer. No. Why?
Not 45%.
It's larger than 1.
You guys are on fire. All right, so where do I need to have my decimal then to make it in scientific notation?
1.5.
Right here. So what do I need to write? 1.55. Do I need this 0?
No.
No, because that's our intention to make it smaller. Times 10 to the
Second. You're only
boing,
going you only
boing,
go 2 spots.
boing.
3 spots.
1, 2, 3. Happen to be the same exponent as up here, just by chance. All right? So that is our final, and we label this what? Centimeters. Oh, we forgot to label this one up here. What was this one labeled?
Liters.
No, we changed the liters to, yep, to the milliliters up there.
Already changed. You put it in the box.
All right, now let's practice this type of problem. Applying, you're going to decide, am I going to multiply this information that they're giving me, or do I need to divide it? Example 3. On average, the human heart beats 3.5 times 10 to the 6th power times each year. About how many times has your heart beat if you are 14 years old? So that's about like you guys out here. Let's try to get an estimation and see how many times you think your heart has beat in the last 14 years total. What do you think we want to do first?
Convert.
Yes. Okay, so we have a scientific notation. That's how many times in a year. How many times in a year? What does that equal in standard form? Move it how many times? 6. So 1, 2, 3, 4, 5, 6. Put my commas in there. Wow. Approximately how many times does your heart beat in a year? 3,500,000 times in 1 year. That's a busy, busy, busy heart. That's why they say, take care of your heart. Now what do? About how many times has your heart beat in 14 years? Am I going to multiply those or divide it? You will multiply it because it's this much in 1 year. How many in 14 years? Multiply those. What do we get?
49, and then 1, 2, 3, 4, 5, 6 zeros.
A lot of zeros, right? Everybody agree? It's going to be 49 and 6 zeros.
491.
Close. 49 million, yep. So, are we done though?
No.
Kind of. Does it, about how many times has your heart beat? Does it say we have to turn that into scientific notation? No. But say if we did it the other way, when we were learning the other way with virtual Mrs. Lennon when I was gone, times 10 to the 6th power, and then times 14. That's like 14 times 10 to the 0 power. 14 times 3.5 is 49. Times 10 to the, what do we do with our exponents when we multiply? Add them, and what's 0 plus 6?
6.
Are these equal?
Yes.
Okay, so what if you figured it out in scientific notation? Can I circle that and say, yep, that's how many times my heart beats in a year, or in 14 years?
No.
No. You need to convert it and say 49 million heartbeats in 14 years. Simple as that. Right? Example 4. The population of the world is this. The population of just the United States is this. Okay, next example that we need to do on lesson 4.5 is example 8, so you're going to have to turn your page ahead. It's on the bottom, page 20 if it's labeled. Example number 8, the circumference of the earth is 2.5 times 10 to the 4th miles. The Mississippi River is about 2,320 miles. They're asking the question, how many Mississippi rivers are needed to wrap around the earth at the equator? So like we talked about earlier, right? We have to get them either both into standard form or both into scientific notation. So I'm going to show you both ways again. Take this one, 2.5 times 10 to the 4th power. Then, if I change that into scientific notation, it will be 2.32 times 10 to the 3rd power. All right. Now, what do we need to do? Multiply or divide those? You're going to ask yourself how many of these needed to wrap itself around the Earth. So you're going to want to, come on. You want to divide these. When you take 2.5 and divide it by 2.32, you should end up getting about, I think it rounds if you go 1.105 or something, so it rounds to 1.1. You round it to the nearest tenth. 1.11, somewhere in there. And then when we divide, we subtract our exponents. 4 minus 3 is 1. So times 10 to the 1st power. That's your answer you would get. And then we have to turn that into standard form. So you move your decimal place, 1. You're going to get 11.1. Or if you want to just approximate, about 11. But then you need to write on your worksheet too. You have to tell me, what did you just solve for? It's about 11 what? It's going to take about 11 Mississippi rivers to circle the Earth. So I know what you're solving for. All right? Now you could have also done that backwards, and you could have turned that into standard form. 2.5, and then add 3 more zeros. 5, 1, 2, 3. And you could have divided that by 2,320, and you're still going to end up with the same answer. When you round it, you're still going to end up with 11 Mississippi rivers. Okay? So whichever one you want to do, if you like to turn them into scientific notation and then divide or multiply, do that. Or a lot of people think it's easier to turn them into standard form than do your multiplying and dividing. All right, so your homework then is pages 3 and 4 in, nope, I take that back. Pages 5 and 6 in your worksheet packet. Pages 5 and 6 in your worksheet packet.